Hello. In our last video, we learned a bit about what RAG is. This is Retrieval Augmented Generation. And it's a very important tool currently, especially in the LLM space. And it solves a lot of problems with LLMs like hallucinations mainly, and the problem of the context length, right? So hallucinations where when the LLM generates output which is not based on actual facts, right? And another main issue is that LLMs have a lot of context issues because if you need to feed in a whole book to an LLM, that's going to just increase the computational cost by a lot, and by that, the running cost too. So it's a huge problem so that the LLM is able to keep track of whatever was talked to it before, or if it needs a specific domain related knowledge too, but you don't want it to just fine tune the entire LLM in that. So RAG or RAG is very useful in that case because it augments the LLM by retrieving information from a database. That's retrieval augmented generation, right? So in this notebook, we'll try to build an application using retrieval augmented generation, which is a restaurant chatbot. So let's say there are a lot of open source large language models available. There's Llama, Mixel, etc. And even if you pick one up, it's not really ready to be directly used as a chatbot, especially if you have a particular field, right? If it is in the case of a restaurant, you want some specific information from the restaurant. And one easy way to is to use a lot of data related to the restaurant or maybe food related data and can fine tune the model. But that is a bit too much and it isn't that effective either. And you have to retrain the whole LLM. And with something like RAG, what you can do is you can give a database of information like which is specific to that restaurant. Let's say in our restaurant, case, of course, it's a fictional restaurant. We'll just give a small menu, and then this chatbot will be able to ask questions to the menu and answer it. So this has practical applications, of course, because in any chatbot in any commercial application, you probably have a set of information which is specific to that domain, right? So you just take that, and then you can create a RAG pipeline for that. All right. So we'll be mainly using OpenAI API. So it's just ChatGPT itself in this, which we're using. And we'll also use a LangChain for RAG workflow. So if you're not familiar with LangChain, it is a popular framework. And it helps you do a lot of things like let me just go here, like all of these anything related to rags, to store, index, etc. To even you can even integrate it with Pinecone, which we talked about in the last video, because we have a vector database and it makes it easier to make the LLM communicate with any external thing. Or even if you want to do some automated prompt engineering, you want to do chain of thought prompting, all of this which we'll get into. But whatever you want to do, like you want to manipulate in a large language model, LangChain is a really good framework to that. And we will have a part where we look at to LangChain especially. But right now, just know that we are just using the LangChain framework to implement the RAG pipeline here. Okay, so we'll be using LangChain as well. So just to recap from how RAG works, like you search something and then along with the LLM, we also ask it to the embedding model wherever we have the database. And the retrieved context is taken back and it's added to whatever question we asked before. So in this case, if you ask about a dish, it'll go to the vector database, it'll retrieve information about related to that, and then it'll add it to the prompt, and then you can feed it back to, let's say, GPT 3.5 in our use case currently, and then you'll get the reliable answer. Of course, here it's another example, but the flowchart is essentially the same thing. All right. So to run this notebook, we need two things. one is a Pinecone account and an API key. That's free to create. And I've already talked about how an API works. And just a refresher, so they have their programs running in, right, let's go here. So they have their programs running in their own servers, right? And this is our computer, and we have our code running. So what we can do is we can ask for an interface. So we'll just send a message, and we can also maybe have a PDF sent along with it. And this other server where you're storing all the data, because we don't have that much storage space, and the entire software architecture is running there. So it'll understand this message and add our data here, and then they'll also allow you to interact with it, right? So they're providing this whole service. So to interact with this, we need some protocol and some way to speak with the server, right? And that interface is the application programming interface. So like whatever application is running here, you can interact with them with your own program using an API call. So that's why it's called a call, because you're requesting it for something. So if it's an OpenAI API, you're probably sending a prompt, and then what you receive is probably the answer to whatever the prompt is. There's several things that you can do using an API, including control, not just sending data and receiving data. You can even send control messages, depending on how the software provider has defined the API. All right, now back to our code. So yeah, so you need an OpenAI account as well, and an API key. So a Pinecone API key I already showed you in last video. In OpenAI, you can just go to platform.openai.com. You can just go to API keys and you can create a key. If you've already used it up before, you'd probably have to subscribe to it to get a new key. But otherwise, I think they give you a free trial of, let's say, a limited amount of credits. Then you can just get the key from there. So you have an OpenAI API key as well as a Pinecone API key. And mind you that this is just one way of doing it. So instead of Pinecone, you can use any other vector database like VV8 or ChromaDB or anything, or you can even run something locally. And the same thing goes with the OpenAI API, because you don't need to necessarily use this. You can use Mixtral, you can use Llama, all of those open source large language models, and you can even run any of these locally. So you don't need to connect this at all. But there's an easy way to do it, and they have sold it pretty well. So if you don't want to pay for a cloud-based provider, you can do that by yourself as well. All right, let me start running this. So this is what we need to install for this. One is Langchain's Pinecone and OpenAI 2, and even text splitters. This is just because we're giving some content to split that. Yep, that's it mainly. So we are connected to install that. So first we run this to initiate the Pinecone API key. Right, this is still installing. And then we have to get the OpenAI API key too. So, okay, here you can just directly connect to it. All right, that's done. And here, all right, this is the Pinecone API. And this user data.get, this thing I've put, you can just directly assign the OpenAI API key if you want over here. But I've done this just because I've put it in the secrets. Right, I just have the API key hidden here. But you can either do this this is a good way to do it so that your API keys are safe. But otherwise, you can just directly put the API key here too if you're sure that your notebook is safe and nobody will steal your API key. All right, so I think I've run that. Okay, so this is the document we are going to feed in, and this is the name of the restaurant. It's completely fictional. I just generated it off of ChatGPT itself, and yes, it has like all of these headers and also these subheadings. So yeah, this is the main heading and the subheadings. There are appetizers and all of this, and there's a price and there's also a kind of description. So this is of course, this is a very small content, and probably you can just directly send it to a large language model, like open like ChatGPT, etc. You can just directly put it in the chat box. But this is just a demo case. So if you wanted to refer an entire book or even more information, then of course you'll have to use this. So this is just for the demo that we are just having this small menu that we are feeding in as the data. Right. So we have that. So we'll just store it in this. Okay. And now what we also do is we have to chunk the data, right? If you remember from the last video, we've talked about chunking algorithms, right? Chunking strategies. There are several ways to chunk it. So if you have the entire document, you can just have a fixed set size, maybe like a particular length, maybe a number of lines or anything like that, maybe a particular number of bytes, anything of that sort. That's fix it. You can have recursive chunking where you just split by a separator, maybe like a comma, and then you keep doing that. Document based, depending on how it's formatted. And there's also semantic chunking. Okay, and we are using semantic chunking here. If you go back to this, so semantically, what you can do is you can see that there's some kind of structure here already, that there's headings and there are subheadings. So what we'll do is we'll just divide it using these hashtags or like headings and subheading split itself. So we'll define that there. All right, this is what we're going to split on, all of these headers. And we define this. This is how we want to split. All right. Yep, and then we can also print it out. All right, I think I forgot to import this. Okay, now it's running. And this is how it is split. As you can see here, it's a header 1, and then this is what it is. And this header 2, appetizers, this page content. And it's just split like that. So the entire thing is split into this. Okay, so that's how we've chunked this data so that we can retrieve it easily. Okay, so the next thing is you need an embedding object. So we need to embed this somehow. So for that, over here we're just using the multilingual E5 large model, which is there already. There are several, like we have a lot of options how we're going to embed this, but here we're just going to use this. Okay, and next we'll just start integrating Pinecone into it. These are just the configurations for Pinecone, so you can choose which region in the cloud we are using. So we're just using AWS and US Eastern. This is sometimes very important if you have a large amount of data. And here, since it's a demo and it's like a very small data, it's like completely all right, since this application is small. But otherwise, you might probably want to try to optimize and reduce the latency. So of course, you might have to tune that. Okay, now we have this in a markdown format too here. And as you can see, the headers are, there is the heading and this is subheading too, and there is the split. All right, now we just run this. We have this split here and we have how to split this. We're just using the direct library function here. Okay. And we'll just print it out too. You can see it's split according to the headers, header 1, and this is what it is, header 2. So just split there. Now what we need to do is we need to embed this, and then you can use from LangChain Pinecone, this from LangChain library itself, and then you can have Pinecone embeddings. And this is a model which we're going to use, multilingual E5 large. It's a simple model which you're going to use to have this embedding done. Like I said in the previous videos, that there are a lot of ways to have this embedding. You can have transformer-based models. You can have any kind of NLP models which somehow embed this. But we're just gonna use something which is already there, and this multilingual E5 large. Yeah, let me just run that too. Okay, and these are just Pinecone configurations which you'll need to do. And this is just the selection of the region and the cloud. This is not so relevant here. We can just have something like AWS, and we're going to use US East 1. But let's say if you have an application and its latency is very important and you have a lot of data too, maybe it's not wise to use any random region. You might want to use what is most close to you or whatever has the least latency. All right. So we'll just create a vector index now. As you remember from our previous videos, that we'll need to create the name of the vector database. We want to create the vector index, and we want to just name it Italian restaurant for now. All right. And this is similar to what we did in the previous video of using semantic search using Pinecone. We have the similarity metric here, which is like cosine similarity. You're gonna, if we have two data elements, and or maybe like the query, you're gonna see the difference between them, like the cosine similarity. That's how you're gonna see how similar it is to that next data element you're gonna retrieve, right? You're gonna pass all of this. You're gonna pass the index name too, right? Okay, so we have this error that it has to be lowercase alphanumeric characters. I think in the name we missed that. I think that should fix it. All right, we'll just wait for it to create the index. I think that's done. And we'll have this namespace. And in this namespace is what you're going to store all of this. Like the chunks we've already done before, and we've split it using these headers. You're going to store it in this namespace. Okay, just name that. All right. Maybe I can just, all right, I'll just name it the same. Okay, that's done. And we can just, using Pinecone's list, like query, we can just take a look at one of these records, okay? You can see that you have the metadata too. Like we're finding the matches, right? Just looking at one record. It has a particular ID to it, and this we have this metadata. This header 1, header 2. This is the header 1. This is header 2. We're just looking at deserts for now. You just see this. Yes, good similarity score too. Right. So it looks like all of this is stored properly. Let me just check something else. Yeah, it's working well. We've got the appetizers currently, so it's just stored like that. We can just see what's next too. Yeah, second courses are that. So just stored in those chunks. It's just chunked semantically and stored. All right. All right. So we have it formatted and the pipeline kind of set. Now we can just use the chatbot. We can just directly use the chatbot. So for that, of course, we need the OpenAI library function and also the retrieval QA for the retrieval part. And the model we're using is GPT 3.5 Turbo, and we're loading the API key which we have already. The temperature is something which you can increase if you want more varied output. Let's say if you want to give some kind of character to the restaurant chatbot. Otherwise, this will give you a neat output of you the most probable output if the temperature is less. So as you remember, LLMs are models which are predictive in nature, right? It's just predicting the next token. So mostly there is a highest probability for one token which is to be predicted, but this temperature parameter kind of gives you control over that. Maybe you don't want to just give the most probable token next. Maybe you want to create some variation there, so you can just tune with that. All right, now let's use the chatbot directly. And here we'll just try two things. One thing is we'll just directly ask the LLM, which is GPT 3.5 Turbo. We'll ask the question. And that time they won't have, I mean, the large language model won't have any context available, right? Since we already have this document here. And this we won't feed. We'll just ask it directly and we'll see what kind of response it gives. And we'll also ask it through the RAG system. And that time it will also have the ability to retrieve information from the vector database. And we'll see what answer we get. All right. Okay. Just go here. And okay, for this is the first function which is just directly using the LLM. And here we are having with the retriever. Okay. All right, we'll just ask these two questions about. Okay, this is the first question, the appetizer options, and the second is just a vegetarian main course, and also something like the price should be returned. That's what we're asking for. Just run that. Okay, we'll run this too. So the query one with knowledge and query one without knowledge. All right. So let's see. We asked this, and we got, and this with knowledge. Okay, it has access to the system. Um, okay, it says these are the ones. Let's just verify that. We have bruschetta, caprese, and calamari. All right, let's go up. Let's look in the appetizers. You can see, yeah, it's bruschetta, caprese, and calamari. It looks good. So that's working. So, but if you look at the next one, this is okay. It just somehow started with those three, but it just goes and hallucinates. And this is what is exactly meant by hallucination. So the large language model doesn't really know about the actual facts. So it's just hallucinating here. This means that it is creating content which is actually not there. Because all of these things are not really there in the restaurant, but they're giving it anyway. All right. So this is one thing which RAG solves, but RAG doesn't solve that all the time either. But it is a very good solution to the problem of hallucinations in large language models. Let's also look at the second query. And this is the second query. What vegetarian main course options are available? And can you describe one in detail, including its price? Okay, this is the query. They say this a vegetarian main course option available, risotto, and all right, they gave. All right, I think they missed the price. Yes, they missed the price. And the other one, without knowledge. All right. Okay, they just hallucinated here again. And just kept on going. All right. Yeah, I think both of it missed the price. I think we specifically asked for the price. Let me try to change the prompt a bit. All right, maybe that'll help. Let me try this again. Right. Okay, now they somehow managed to give the price. So as you can see, these systems like large language models, and if you use RAG, there are a lot of options to optimize it and what you want to choose, what vector database you want to choose, and how you're going to engineer the prompt, what kind of prompts you're going to use. Are you going to automate the prompt too, or are you going to send several prompts, get the best answer? How are you going to rank the responses? All of these are very important choices when you're using RAG. And there is no definitive answer to what is the best RAG pipeline, etc., because that's something you need to work with. It's somewhat like hyperparameter tuning itself in machine learning, and this something you can experiment with and see what works best with you. And of course, you can be the judge of the responses yourselves in these systems. All right. Let's also look at the other option. We asked the same question, and let's see if okay, they did go to the prices for which can vary, right? It says it can range from 10 to 15, but in actuality it was $26, and you can verify this as well. If you go up, yep, risotto is $26. Okay, so if you're going to implement a chatbot with a large language model, and if you want to beat some of the problems like hallucinations, an RAG is a really good option there. And this is just one application of RAG. We'll see into more advanced applications too. We'll see what else we can do with RAG. All right. And just before going, we'll also have to clean up the index too, so that we just save the space there. And that's it. I'll see you in the next video.